Hello, scholars. We are back in the science lab and we are still talking about the physical property of mass. Today, we're going to understand that matter has measurable physical properties that determine how matter is classified. And remember, to classify is to, you can say it's to break into groups. And we can do that by comparing and contrasting different masses of different objects. So we're going to actually use an old school balance today. We're not going to use the triple beam balance, just a regular balance beam. And what we're going to do is we're going to stick one object on this side, one object on this side, and then you are going to make a comparison about the masses of those objects. Are you ready? I hope you're ready, because I'm ready. I stay ready. I hope you stay ready, because if we stay ready together, guess what? We'll be ready. All right. The first two objects that we're going to use, the first one is a prism. Prism is a scientific tool that we use in the science lab that refracts light. Refract means to bend the light. It doesn't mean to take it and bend it like a beam, but it means to bend it as in change the direction of the light. These are really, really cool. And when we get to the study of light, you'll get to see some really, really cool things come from this. And the other tool that we're going to use is a horseshoe magnet. And I'm pretty sure you can guess right now why they call it a horseshoe. What? It's in the shape of a, yes, you said it, horseshoe. We're going to use this horseshoe magnet and this prism to compare masses. Now, I want you to take a second and stop and think. Look at the material that they are made out of. This one is made out of metal. This one is made out of some glass-like or plastic-like material. And I want you to ask yourself, what object do you think is going to have the most mass? What one is more compacted together? Are we ready? I think you're ready. I hope you're ready. If you need a moment, you can pause it right now. All right, we're back. I hope you're ready. Horseshoe magnet is going on the left side. Do you want to do the horseshoe magnet first or the prism? Horseshoe magnet or prism? I'm trying to read y'all's minds right now. Say it out loud. Say it out loud. I heard you. Somebody said, do the horseshoe magnet first. So that's what we're going to do. I've got my horseshoe magnet in. Okay. Now the horseshoe magnet has clearly rocked my boat all the way down. So now let's see what's going to happen when I put the prism in. Oh, okay. So I'm going to help you with the first one, but all of the rest ones are up to you. Remember, the object with the most mass will go down. So the horseshoe magnet stayed down. That means if I was to make a comparison, I would say that the mass of the horseshoe magnet is greater than the mass of the prism, or I could also say that the mass of the prism is less than the mass of the horseshoe magnet. And don't forget, a horseshoe magnet is a tool. It uses the physical property of magnetism, and we will talk about that later. So we've got two tools down, and we know that the mass of the horseshoe magnet is greater than the mass of the prism. Next up is a tennis ball and a battery. Now, a battery is a tool that we use as a source of energy for our circuits. When we get to circuits, we'll talk a lot about that, but it is a source of energy. And this is a tennis ball. And it's a tool that I use for my ADD. Whenever I'm having trouble focusing, I will play with this ball. So that's exactly what this is. It is a tennis ball. There's nothing special about it. I would really like it if it was in the color blue, because that's my favorite color, but it's not, so we'll deal with it. Make your observations now. What object do you think will have the most mass? What object do you think will have the least mass? And I want you to write that into some kind of explanation. I think that blank will have the most mass and blank will have the least mass. And if your teacher is really on it, they can make you give an explanation as to why you think that. Knowing what is important, knowing why is so much better. All right, here we go. Take a moment, pause it, talk, teachers, whatever, students, go, and we'll be back, and then we'll go. All right, we are back. Here we go. What object do you want to put in first? Tennis ball or the battery? Ooh, somebody just laughed at me. Don't laugh at me. It's not funny. I'm thinking. Okay, I got you. We want to go in with the tennis ball first this time, okay? That's what I'm just feeling it. That's what I felt. So we're gonna go in with our tennis ball first. Tennis ball shot down, like it's down fast. It dropped the mic for real. Now we're gonna go in with our battery. Let's see what happens. Make your observations. What do you think is going to happen? Remember the history of our battery? Remember what mass is, the amount of matter that is compacted. How dense is that matter? Put off in there, dense, close together. Is it squeezed in really tightly, or is there a lot of space? Or is it squeezed in really tightly? Okay, here we go. Battery's going in. Wow, make your observations. I'm not going to tell you this time. You should be able to tell me. We saw the battery do this, the tennis ball do that. What does that mean about the mass of these two objects? What kinds of comparisons can we make? Can we make one comparison using the word blank has a greater mass than blank? We could also make another comparison saying blank has a least mass or less mass than blank. And you can do that now. Last but certainly not least, if you didn't pause it, make sure you pause it, because I'm back and I'm live. So if you need to stop, stop now. Last but certainly not least, we're going to use two more scientific tools. We are going to use a hand lens and we are going to use a pipette. Now, pipette is a tool that is used to get droplets of things. When we get to mixtures and solutions, we'll use a pipette at times. There will be times where maybe with solubility, we might do a pipette lab where we'll need to pull up some liquids and then put small amounts of it out with a drop. If you've ever been sick and mom might have got the medicine and used a pipette to stick the nasty medicine in your mouth. So if you've had a bad experience with a pipette, I promise you, it's a scientific tool, you're okay. But another tool that we use is a hand lens. And this hand lens right here allows us to magnify objects. It allows us to take small things and make them look bigger. So I can actually stick my eye behind there and it looks huge. And you look huge. Everything looks huge because that's what hand lenses do. They allow us to look at tiny things and make them larger. That's called magnify. They magnify them and make them larger so that we can see. My paper looks huge right now. I promise you that it does. You're going to have to take my word for it. But when you're back, you will see for yourself. All right. Hand lens and pipette. What's your observations? What do you think is going to happen? What one do you think is going to have the most mass? What one do you think is going to have the least mass? And why? And you can really think through this one because think about what a pipette does. It has to suck a liquid up into it. And if it has to have space to put something in it, what does that tell you about the inside of a pipette? Use your knowledge of science. All right, teachers, you can talk about it or you can pause it now and have your children make their observations. All right, here we go. I have my hand lens. I have my pipette. I'm about to get off into your mind so that you can tell me what one that you want to go first. Here we go. Oh man, people are going on both sides. People are going on both sides. Some are saying pipette, some are saying hand lens. Both of these are amazing scientific tools. Let's go for it. I'm going to choose hand lens is going first. All right. I'm going to put it on the right this time. Hand lens is down. Time for my pipette. Oh, wow. So the hand lens is here. The pipette is here. What observations can I make by comparing the masses of those two objects? What observations can I make by comparing the masses of those two objects? All right, we have one more final activity. One more final activity. We are going to compare the mass of a paperclip, and everybody's seen a paperclip, with the mass of this balloon. Paperclips are made out of metal. Balloons are made out of plastic. What do you think's going to happen when we compare the mass of the paperclip and the balloon? Make your observations now. What do you think? I know what I think, but I've done this before. Have you done it before? Probably not. All right, here we go. I'm going to put these in, and we're going to make our observations. What one do you think has the most mass and why? What one do you think has the least mass and why? What am I going to go first with this time? The balloon. You want the balloon? What? Okay, here's the balloon. I'll go the balloon first. Will of the people. Will of the people. Can I even get the balloon in there? Let's try the skinnier end first. All right, so we've got the balloon in there. And now the paper clip. Metal. Here we go. What? The balloon went here. The paper clip is here. How can that be possible? A paper clip is made out of metal. This is plastic. I don't know, but you know. Actually, I do know, but I hope that you know by now. Make a comparison between the paper clip and the balloon as your final comparison. Now, when you're done with that, teachers, you can pause it if you need to pause it. Time out. Rocky. Okay, when you're done with that, here's what we're going to do. I want you to make a comparison for your DOL between the chair that you are sitting in and this balloon. The chair that you are sitting in and this balloon. What one do you think has the most mass? What one do you think has the least mass? And I want you to explain to me why. In everything that you do, we always have to tell why. Why is so important? Why? Why are you asking me why? Because why tells me what you really understand about the concept of mass. Hope that you guys enjoy everything that we did today. We have been comparing the masses of different objects, and we even got to do it with really cool science tools. I hope you learned about some science tools as well, and we'll be back with more physical properties to explore soon.